Okay, here's a wild thought for you. What if all motion, everything you see, from a thrown ball to a car driving down the street, is just an elaborate illusion? What if reality itself has a frame rate, just like a movie? It sounds crazy, I know, but let's dive into this.
Now, I know that sounds like something straight out of science fiction, right? But believe it or not, this is a puzzle that's been bugging philosophers and physicists for more than 2,000 years. And to even begin to untangle it, we've got to start with an illusion that you and I see pretty much every day, one that our brains fall for every single time.
Yep, I'm talking about the movies, the magic of cinema. Every film you've ever watched, from the biggest blockbuster to a home video, is built on this one simple fundamental trick. It's a trick that totally exploits a weird little quirk in how our brains process the world around us.
So the sciencey name for this is the stroboscopic effect. Basically, your eyes hold on to an image for just a split second after it's gone. So when a whole bunch of still pictures are flashed in front of you one after another really fast, your brain doesn't see a slideshow. Nope. It actively fills in the gaps and says, hey, that's movement.
Think about that for a second. There is literally no actual motion happening on a movie screen. It's all just a sequence of frozen moments. You get one static frame, then the next one, which is just a tiny bit different. Do that 24 times every single second, and our brain just stitches them all together and creates this illusion of smooth, fluid motion. Now hold on to that idea of frozen moments, okay? Because it turns out an ancient Greek philosopher used an almost identical concept to try and prove that all motion is logically impossible.
All right, let's fire up the time machine and head back about 2,500 years. We're going to meet a guy named Zeno. And Zeno, well, he came up with a brain teaser so good, so powerful, that people are still arguing about it today.
The setup is super simple. You've got the legendary hero Achilles. We're talking the fastest runner alive. And he's in a race with a really slow tortoise. To make it a bit more of a challenge, he gives the tortoise a head start. Now, common sense screams that Achilles is going to win this thing no problem. But Zeno's logic? Well, it tells a very different story. Okay, so here's the trap. For Achilles to pass the tortoise, first he has to get to the spot where the tortoise started, right? Easy enough. But in the time it takes him to do that, the tortoise has crawled forward a little bit. So now Achilles has a new, shorter distance to cover to catch up. But while he's covering that distance, the tortoise, you guessed it, moves forward again. You see where this is going? This just keeps repeating, over and over, creating this endless, infinite series of smaller and smaller gaps that Achilles has to close.
And that brings us to Zeno's brilliant and honestly kind of infuriating question. How can you ever finish an infinite list of tasks? If Achilles has to complete an infinite number of these little catch-up jobs, how does he ever actually pass the tortoise? Logically, it seems like he can't. The race should go on forever. So what gives? Is reality broken? Or is there a flaw in Zeno's logic? For almost 2,000 years, nobody had a good answer, until a revolution in math gave us a brand new weapon to fight against infinity.
And that's where calculus comes in. This whole new branch of mathematics, cooked up by geniuses like Newton and Leibniz, finally gave us a way to really wrestle with the idea of infinity and actually win. It made infinity something concrete, something predictable.
This quote really nails the core idea. See, Zeno's whole argument was based on an assumption that if you add up an infinite number of things, you have to get an infinite total. Makes sense, right? Well, calculus came along and proved that our intuition about this is just flat out wrong. The secret weapon here is something called a convergent series. Now, stay with me. The idea is that if the little pieces you're adding together get smaller and smaller, and they do it fast enough, the total sum doesn't just shoot off to infinity. Instead, it closes in, it converges on one specific, finite number. It's kind of like this. Imagine walking halfway to a wall. Then you walk half of the remaining distance, then half of that distance. You could do that forever, taking an infinite number of steps, but you'd never actually walk past the wall, would you? So, when you apply that same logic to the race, you can actually calculate the tiny bit of time it takes Achilles to run each of those infinite little segments. And when you add all of those infinite little moments up, calculus proves that it all adds up to a very specific, very finite amount of time. The math tells us the exact moment, the exact spot where Achilles finally catches the tortoise. So, case closed, right? Problem solved? Well, not so fast, because solving the math problem just uncovered a deeper, trickier philosophical puzzle. Okay, the total time is finite, we get that. But can you logically complete an infinite to-do list if there's no last task on the list?
This is what's known as a supertask. Here's an example. Imagine you flip a light switch on for 1 minute, then off for half a minute, on for a quarter of a minute, off for an eighth, and so on, forever. The crazy thing is, that entire infinite sequence of flips will be over in exactly 2 minutes. But here's the question. At the 2-minute mark, is the light on or off? There's no final flip, so the final state is, well, it's logically undefined. So yeah, the math problem is solved, but this logical weirdness is still hanging around.
And this brings us to the most modern and honestly the most mind-bending solution to this whole thing. It's a solution that doesn't just play Zeno's game. It flips the whole game board over. It asks, what if Zeno's most basic assumption, the one his entire paradox is built on, was just wrong?
See, Zeno's logic only holds up if you can keep dividing space, chopping up distance into smaller and smaller and smaller pieces, forever, with no end. He was working with the idea that space is perfectly smooth, a continuous line that you can divide infinitely.
But what if that's not actually how the universe works at its deepest, most fundamental level? What if you could zoom in, way in, and find that reality isn't smooth at all? What if it's pixelated, made of tiny, indivisible units, just like the frames of a movie?
And this isn't just some wacky philosophical thought experiment either. We're talking about theories on the absolute frontier of physics, the stuff trying to connect gravity with quantum mechanics. They take this idea very seriously. Some theories imagine space-time as this chaotic, bubbling quantum foam at the tiniest scales. Others, like something called causal set theory, basically say that space-time is built from a finite number of fundamental atoms of space-time itself. Physicists even have a name and a number for this theoretical minimum distance. It's called the Planck length. And look, the number it's ridiculously, unbelievably small. But the most important part is that it is not zero. It's a real, finite length. This is thought to be the fundamental pixel size of our reality. You literally cannot have a distance smaller than this.
And if that's true, if space has a minimum pixel size, Zeno's paradox just vanishes. Poof, gone. The race is no longer about an infinite number of divisions, it's just about crossing a massive but finite number of these tiny Planck-length pixels. The whole problem of infinity was just an illusion, one that was created because we made a false assumption about how reality is built.
Okay, so this is where it all comes together in a final, really startling way. Remember how we started with the individual frames of a movie creating the illusion of motion? Well, now that we're talking about a pixelated, frame-by-frame reality, quantum mechanics brings us full circle in the most bizarre way you could imagine.
This connection between the frames of a film and the possible frames of our universe, it's more than just a nice analogy. It turns out that the very act of observing something, of measuring it, can be like hitting a pause button on reality itself.
It's a real thing. It's called the quantum Zeno effect, named of course after the man himself. And the principle is wild. It says that if you have an unstable quantum system that's about to change or decay, you can actually stop it from changing, just by looking at it, by measuring it over and over and over again. Each measurement basically resets it to its starting position, effectively freezing it in time.
This is almost literally the quantum version of a watched pot never boils. By constantly observing a system, you prevent it from moving on to the next frame of its own story. So here we are. The illusion of motion we see in a movie theater crashes right into the quantum reality of a universe that might, just might, be made of frozen moments too.
So, look how far we've come. We started with a simple foot race, we dove into calculus, and we ended up questioning the very fabric of space-time. And it leaves us with one last, huge, fascinating question. If our reality is truly made of frames, like a film, progressing from one tiny, discrete moment to the next, then what in the world is happening in the dark spaces between those frames?